So this time we're going to get into developing our software solution, and we're going to focus on it's object-oriented design, but it's sort of the getting ready for object-oriented design. Much like we did getting ready for the database, we're going to talk about some of that stuff on the object-oriented design side of it. As I've mentioned before, this is going to be essentially a two-parter. We're going to talk about general stuff this time, and then I want to get into patterns and usage of software patterns and even potentially anti-patterns. But it's a big enough topic that I'm going to have to hit it, in a second presentation. So we'll cover that in a few weeks. And so those two combined will be a sort of like a mini software design class. So getting us to where we started, or from the start to where we are today. We start out with a problem to solve, and if it's been a while, so you may have forgotten that this was going to be a goal tracking application. We built some requirements and use cases, and we've kept it pretty simple. A goal tracking application has turned out to be a nice, simple kind of app to do. I mean, you've got goals, you've got work done, progress done on those goals. You got users, and then some reports and things like that. So that was pretty simple requirements and use cases. We took that and talked about creating a clickable demo, something that's a wireframe or something so that you can start putting these concepts into concrete so you can see them, play with them, and adjust accordingly. Because some things look great on paper and they don't look great when you translate them to the web. We went into the user experience side of it because we had our clickable demo, so it made sense then to move into some of that framework kind of work, things like the styles, what's the basic look and feel going to be, how do we want the navigation to look, so we can build some templates for our pages. We can build, use CSS and style sheets, maybe even do some global JavaScript type stuff, as well as pick some of our libraries, for example, like Bootstrap if we want to be responsive, jQuery if we know we're going to do a lot of JavaScript, things of that nature. And then we flipped from the front end and all of that to the back end, and we looked at designing a database. That brings us to our next step. So now in our life cycle of our product, we're basically getting into the implementation phase. I mean, really, when we started the database, we were getting into that because we're creating a physical and a logical and physical structure for the database. So we were writing some code and creating tables and things like that. So now we're getting, that's maybe the ramp up into our implementation phase. Well, now we're definitely getting into implementation phase. So we need to consider our code. What are we going to do with it? What kind of structures are going to be? Any like standards and things like that we want to follow. And so for this one, because of just what some of the topics we want to cover, we're going to look at an object-oriented approach. And this is going to be actually a fairly simple model from an object-oriented point of view. We're going to talk a little bit about some more complex things we could do. The analogies are a little bit of a stretch because there's just not, this is just very nice and cut and dry. But there are some considerations to worry about, and that it gives us sort of a baby steps into object-oriented. And part of it too is because most modern languages support it. It's pretty common. Even stuff like PHP that's not object-oriented as a language, it supports classes. With them, it supports things like inheritance and some things like that, which are some key pieces of object-oriented. As I'm assuming at this point, the key things being encapsulation and inheritance and ability to do. And I lost the last word, but it's the ability to do functions with multiple signatures. The reason that we're diving into all of this and going the object-oriented route is to, the silver bullet of object-oriented has always been code reuse. It's trying to do as much as possible with as little possible code because it's easier to maintain. You can change stuff in one place and that covers all your changes. You don't have to copy and paste 1,000 different places. You don't have to worry about copy-paste errors that could happen in 1,000 places. The flip side of that is that if you make a change in one place and break it, you break it everywhere, which in the implementation side, it's not that bad a thing, because if it breaks quickly and very visibly, which, as developers, it's really, when you think about it, that's what we want. If I'm going to write bad code, I want it to be in my face right away that was bad code. I want, like, flames to erupt and warning sirens to go off and all that. So I know, all right, I got to go fix that. It also provides for scalability, just because, you can only copy and paste so much. And if you start getting into something where you've got the same code written dozens or hundreds of times, it just becomes a nightmare to make any changes, to moving into maybe a different environment where now you've got all of these values that you've got to change to map that new environment. It's just one of those things. It's much easier for us to take this approach, even on a small application. Once we get into maintenance phase, and even while we're in the implementation and doing testing, we're going to be happier, I think, that we did an object-oriented approach as opposed to maybe a functional based. You could do some of the same things in a functional based, and in PHP, you're actually sort of forced to do that in a little bit. But because it's not completely forced to do that, it still makes sense to go the OOP approach. It's also going to make it easier for us to, once you put something like this together, if you build your objects correctly, it's one of the best things about them is it makes them easier to extend. You sort of have built-in hooks, and you can shut them down, but for the most part, unless you almost intentionally do it, you're going to have hooks built in, if you do it right, to be able to extend your application later, plug in other pieces and make it do more and make it grow and become a sort of a living application. So getting started. So, we're going to agree that everybody's bought into this whole object-oriented approach. So now we're going to get started. We're going to work on a design. What you're going to find is there's a lot of similarities between software design the things that we discovered and covered in database design. Start with our core objects. It's really our core data objects. We already did this for our database. Similar thing, we've already pretty much have already identified them since we built our database. So we just are going to keep that list and say, okay, here's the core data objects we're going to work with. Sort of along those same lines, I guess, sort of launching off of that, is we're going to look for buckets of core functionality. And by that, what I mean is thinking of, and this is where you sort of have to go back to the use cases and the requirements, but there's going to be functions that this stuff needs to do as part of the solution. Across your core data objects, you're going to do things like, CRUD related stuff, like, storing it, retrieving it, things like that. You're also going to do manipulations. So it may be, roll-ups of data. It may be, maybe you got something where, if I affect this, I need to have some sort of cascade or trigger effect somewhere else. But if you look at those functions, if you sort of list out what are the key, really, like, use cases and steps, which we've already done in our use cases, we can look at those and we can see where there's essentially like a punch list of functions and functionality that the application has to support. And then when you look at that punch list, you're going to see that there is, for the most part, there's probably going to be a natural grouping for them. Some of those functions are going to be around certain data items. Some are going to be around, for lack of a better term, the general environment kind of things. And this would be stuff like a login, log out, logging, things like that. And there's going to be a few that you're going to have trouble figuring out what bucket they go in. You may be able to do like a utility bucket that they just, sort of the things that everybody needs access to, but it doesn't really fit anywhere. Or sometimes you end up just doing a square peg and round hole, and you look at it and you say, well, this could be here or there, but I'm just going to pick one. And so you're going to put those buckets together. And then with that, now that we've got our punch list and we've got all our classes together, we want to make sure that as we're looking at these functions, what kind of data is always going to be required? Is there something that we're always going to be keeping track of? For example, like an authorization token or a user ID, or something like that, or an IP address or something, which in modern applications, particularly web apps, there usually is. I mean, it may be hidden in the session, but there is at least, maybe not in the URL, but at the session level, there is some consistent data. There is a state that you're in. I mean, if you're writing a stateless application, may not have to worry about it, but usually actually you're more likely to have to worry about it in a stateless application because you're going to have to pass information in all the time. It doesn't have anything storing the state for you. So taking these, for our example, like I said, it's really simple. We had our goals. So we're going to have a goal class that's basically going to have our data for tracking goals and the related functions. We've got users, which are the people that are using the system. And so there's going to be authentication stuff like a login and a password and account data and some things like maybe like an ID and some things like that so they can link to their goals. And a work class, which is basically getting work done on or towards a goal. So real simple for our example. Now we've got those, we've got our core data. Now we're, as I talked about, sort of doing that punch list, we want to get into that grouping of processes and functions. And again, it goes back to, we've covered this a little bit, but it's, as I just said, you're going to go back to those use cases, go back to those requirements. You built that punch list, you start pushing these into different groups, and it's sort of a plan it, do it, review it kind of thing. So you're going to look at that requirements, you're going to look at your use cases, you're going to put all of this stuff together and filter that, assign them out within your core data classes and maybe your catch-all bucket. And you're going to come back and make sure that the functions that you have match the what you started with as far as requirements and use cases. During this process, we want to look for repetition. If we see that, like for our example, across our for goals, users, and work, there's going to be some things that we're always going to do. The obvious simple ones are CRUD. We're always going to want to be able to save data. We're always going to want to be able to retrieve data. There's some other things that you may always do. You may be always maybe converting dates from one format to another, doing some type formatting and casting. There may be some things where you're always appending data or tying data into some global session ID or something like that, or auditing stuff. So you may be always tracking any changes. And then of course that means that you would have this repetitive work of taking a bunch of data and trying to see if it had changed from what's on the database. So you want to see if you've got some stuff that's repeated a lot for a couple different reasons. And I'm going to cover those in just a minute. First, so again, some of the common things are the CRUD, which is create, retrieve, update, delete. If you ever see CRUD, that's what it is. It's the most elemental things you do with data, and it covers all of them. You're either creating data, you're retrieving it, one record at a time or as a list, you're making changes to it, which is updating it, or you delete it, which could include like archiving it or deactivating it or something like that. But really, if you're archiving or deactivating, that's really more of an update than a delete. On the user, we're probably tied to the user, but we're not. You could put it in a general class, which you may have to depending on your framework. Like if you use Hibernate or something like that, or like Spring's built-in security in some of their pieces, you'll have stuff where the authentication may not be part of your app; it may be part of the internal framework. Database configuration and connections may be the same way, but if you're building your own, those probably group pretty naturally. Your aggregation and transformation of data, like I talked about, like casting, typecasting, formatting, some things like that. And then, of course, the last things that we haven't really mentioned yet are like your business rules and events and processes. So these are the things that allow they're really like state transition type functions. So things that will allow your application to step from one state to another. Depending on how the application is set up, you may need to do that. That may not make any, may not be pertinent to your application. In our example, that whole events, rules, process, flows, there's not going to be a whole lot to it. I think there's going to be, you would have something like complete a goal would be something that would probably be an event type code function that you're going to build at some point, a method you're going to have to put somewhere. You're going to have to be able to apply work. and probably have something to do with completing work on a task. And then maybe some things about like how to build, depending on how complicated you get, how to build, for example, like quarterly tasks out of annual tasks, and how to build weekly tasks out of monthly tasks. So there may be something like that that's essentially a sort of a process kind of function that goes out and grabs some data, presents some data, gets some feedback, and then moves on to the next step. Some non-core methods that don't have to do with the core data are going to be things like organizing data for view, things like listing, sorting, filtering, some things like that are going to be data specific, but you may be able to abstract those to a high level. Definitely notifications, messages, emails that are sent by the system are almost always going to be, especially modern applications, those are going to be out there in some way. Combined with that a little bit at the bottom there, exception handling, errors, and logging, those may all fall into the whole notifications and messages and email, which is basically just sort of the guts of the application and what it does when things break and what it does to notify people when things are successful or not. And then, of course, you got to deal with multi-object processes and like controllers and things like that, things that don't fit in any one particular class, but actually would be at a meta level, maybe that's actually the glue among classes that's actually interacting, needs access to a couple different objects or a couple different classes to do whatever that work is. These are going to usually be more like transactional type functions and things like that. So in our example, CRUD always exists. So we're definitely going to have that. We're going to plug that into each of our classes. Listing and reporting data, which pretty much is the retrieval side, but when you consider the additional stuff of maybe doing some manipulations, so maybe client-side manipulations like sorting and filtering. So we're going to have some of those kinds of pieces without having to go all the way back to the database to reset it. Along with that would probably be like maybe if you want to have some mechanism to cache your data, so that you're not having to go back to the database as much, and particularly static data like lookup tables and that. You may want to have those, some functionality for that. Cascading updates and side effects, as I mentioned, things like, hey, if I complete a task that's at let's say at a month level, then I need to make sure that I somehow roll that work up to the quarter level and the annual level to affect all those goals so that everything is in sync. Synchronize that data across all those different types of objects that are going to be out there. Security, logging, and notifications, that's sort of a gimme. And then the other thing that we really haven't touched yet, but falls into, shows up a lot, is obviously going to be data validation. This is going to be at the front end to make sure that the data is entered properly, but also in the middle tier. The database on the back end has already got referential integrity hopefully built into it if you did it correctly, but you're also going to want to do some validation in the middle tier to make sure that the things that you're sending to the database, that you're not forcing it to barf up some exceptions where possible. You can catch it, the closer you can catch it to the front, the less resources you use and the quicker the user can get a message and correct it. So now as we're starting to get into building these functions and methods around these classes. So one of the biggest challenges I found with people when we get into like a really thinking about object-oriented design is they try to get too small, too minute. So, example that you see all the time are getters and setters that are typically like one line of code kind of things. Those are not bad because it has to do with accessing data and things like that. But sometimes you'll find people that, and that's what it tends to be, you get sort of into a mode and you're cranking out all of these like 2, 3, 4 line method calls and functions because you want to make things as reusable as possible. So like every time you have a loop, instead of looping on 5 lines of code, you actually extract that out to a function somewhere. And that can be a pain in the butt. To me, that's what I refer to when I think of sand, is that you've gotten too granular. What you really want to do when you're putting together an object-oriented application is think more on the line of Legos, something that is well-defined, has inputs and outputs, and plays very well with other things within that system. You do still want to make sure your function, your methods are not too long. If you're getting into hundreds of lines of code, you probably have an option there. You probably have something that's a good target for maybe making that a little bit smaller. Maybe just pulling out a section of that code and turning it into a method, even if it's a private method on a class. If you get into thousands of lines of code, then you definitely need to look at that and simplify it. And that's, again, yes, there's a cost for pulling stuff out and abstracting it out into methods or functions, but the maintenance cost can be a nightmare. It's just, as you do that, you want to make sure that it's very easy to find the code that you abstracted it to. The good news is, with the IDEs these days, it's like a click. Almost everything, you can go click on a function and then select the jump to definition. It'll get you right there. So navigating code is becoming a lot easier with object-oriented programs. Avoid side effects within code and try to keep to simple single functions, other than like multi-step transactions where you can. If it's a multi-step transaction, that definitely should have a method or a function for each of the steps, simply because when you get a whole bunch of stuff in there, it gets really hard to follow. And side effects are the worst, because you have all these things that don't necessarily, you're going through flow, you're looking at code, you're working with an object, and suddenly you have this other thing out of nowhere that's getting changed as well, and it can become very confusing as to why it's there. You may forget about it if you go away and come back to it weeks or months or years later, and definitely new developers looking at it may say, what the heck is this there? Maybe I don't even need it there. So if you do have side effects, comment the heck out of it. Remember the goal, like Legos, clean interfaces, and it's not just small chunks of code. You want to have something that makes sense and is easily plugged into other pieces of the system. Don't be afraid to stack multiple interfaces where applicable to maintain a single primary function. And what I mean by that is when you've got something that's used all over the place, for example, like a print or a output to the things that you see a lot is like print, whether it's print to screen, print to file, log to file, convert to string, stuff like that. Don't be afraid to make that like if the language supports it, an interface, and then put the bulk of the work in the interface. If you can put code in an interface. And if you can't, the important thing there is just for consistency. Yes, it's an extra step, and if you're worried about speed and performance, then it is a cost. But from a maintenance point of view and a clean API point of view, it helps a lot, because that just enforces that, if I do object.print anywhere in the application, I know basically what it's going to do. Yes, you could code it differently, but ideally, everywhere you see the print function, it's going to be basically the same thing. Maybe a few little tweaks here and there, and you're off and running. And so that way, when somebody looks at the API, they don't see like print in some cases, write in other cases, print object in another case, display in another case. All these different things you can do. Use those to maintain some consistency in your objects and their methods. Inheritance. This is one of those things where sometimes people get out of hand. It should be like a natural kind of inheritance. Don't just force it. For our example, for our goals, since we have annual, monthly, and weekly goals that we're going to track, we could make that, there could be a goal class that's a parent class, and then each of those could be subclasses, or could be children of it. Be inherit from goal and get most of the goal stuff, and maybe, but the only thing you would change in each of those is maybe the type, or something like that, which is, nice if you got a strongly typed language, you really want to push that, but you're not going to, there's just, and me thinking about it, I didn't see where there's a lot of it, really, there's going to be no substantive difference between those child objects. So in that case, don't bother, make it like a status or a type or class type ID property of the class that allows you to distinguish between those different types. If they're continuing, if they essentially all have the same data and same basic functions and methods that they do. Consider global actions for high-level root object. I've done this a couple times, and it's actually turned out to be pretty nice as far as being able to wheel and deal with objects as you get deeper into, you get into some larger applications. And by this, I mean that you maybe have a core object that all of your other non-visual objects inherit from, and it has things like an ID, save, update, delete, all of the, it's got functions that it does, particularly if you have reflection or something like that. You may be able to code all of that stuff in a core object, and then it just uses reflection to get the child level properties. And then you're able to wheel and deal with objects really fast. You're able to spin new objects up quickly, or new classes up quickly within your application, and it really eases development. This is actually very valuable with visual objects as well. Having a core object, which most UIs now have that in some way, form, or fashion. They've got the equivalent of object that's the core, that has some basic stuff like an X and Y coordinates, display enabled or disabled, and some of those other things like every object has, and you can do some of those pieces within the core class. It's not so much an interface there. You actually have code in that core class that provides you a lot of the work, and particularly the redundant, repetitive kind of work that just really stinks when you're trying to crank out code. So those would be some of those global actions you want to consider. And again, as I just mentioned, the parent objects, you want to have some code in there. You don't want them to be just an interface. You want to make sure, and you don't want something where you look at the parent and like every child overwrites all of the methods. If there's code in the parent, it should be applicable to half of them or more. They may extend it. I can usually see that in a regular case where the parent does a lot of the work and then the child classes are extending stuff. But if they're flat out overriding it, then you probably need to look at your hierarchy a little bit better. And finally, as you're looking through this stuff, consider exactly as I've talked about, your interfaces versus your hierarchy. Interfaces where you have, quote, a parent or root object that doesn't have any real code in it. The only similarities are the signatures for the functions or the method calls. Go with an interface. If you can put some code into that where it's useful to the children and going to be reusable, definitely go with your hierarchy. That leads us to plugins and shared code. Where you find code that's being written over and over again as you're going through it, whether this is like through code reviews with a team or if you're an individual going through it, when you find yourself doing the same thing again and again and again, that's a good candidate for abstraction. It may be a helper object, it may be a plugin, it may be an interface. There's a lot of different ways you could do it. It may just be a static code block. It's things like things that you see a lot would be like on a web application would be the code to check to see if a user is authenticated properly and maybe do some stuff around that. I've got one case where got an application where it checks your authentication every page, and it actually, because of the way it works, it updates all your user data as well within the session whenever you hit a page, so that you're always up to date, so you don't have to like log out and log back in. Something like that is a good example of something that you want to have as a either in a root level object or create some sort of like utility or globally available class or method. You want to centralize your process flows. And by this, what I mean is you don't want to spread the flow and the business logic stuff that are about the application, not about the individual objects, but about the interactions between the objects. Find like a central place to do that. You see this a lot in things like, Spring. They've got their interfaces. When you do the web flow, you've got a flow. You put it all in one place. It's all defined in one area, so it's pretty easy to see what are your actions. You see it in actually a lot of the modern UI templates. You have sort of that concept of like a major, like a primary like bus of flows. And it's just easier to go to one spot to see, okay, where does this, how's this thing work? Try to do whatever you can to keep configuration stuff outside of source code. as far as doing all this. So you may have an object that does a configuration, but even then, ideally it reads from like an INI or XML file or something like that, or a properties file or something. Just that way you don't have to change code whenever you move to a different deployment. Do what you can to limit your assumptions on your methods, on your objects. It's going to make it easier to integrate. If you don't assume state, then it's a lot easier to integrate stuff in. Again, thinking Legos. Legos don't assume that they're going to be plugged into a wheel, or they don't assume they're going to be plugged into a person's feet for one of the little Lego people. So the more you can limit your assumptions for what is going to use your block of code, the more powerful it becomes. Basically, it becomes much more that Lego. It becomes a self-contained interface where you plug some stuff in and you get some stuff back out. Through all of this, you're making design decisions. So make sure as you're doing it that you're adding comments, you put some documentation together of some sort, even if it's a little note here or a little note there. If you comment as you go, you're going to be much happier at the end of the day, because you'll have that paper trail as opposed to a, why did I decide that, moment. So when we're looking at modern software, there's a lot of stuff out there that does these things for you. So avoid reinventing the wheel. If you're trying to do something, Google it first. Google whatever you're trying to do in that language. It's probably already been done. It may be a framework. It may be a command on that language. It's just too many things have already been done, so there's no sense going out there and trying to be the smartest guy in the room when you're better off being the fastest guy in the room. You can go find a proven solution pretty quickly. Don't be afraid to do things like batch and offload processes, particularly if speed and response times are important. There's going to be things that like pulling reports and stuff like that. Sometimes it's just time consuming. So if you can find a way to do that offline, essentially, so maybe they just submit a request and then you email them when it's done, or they can come back later and check on status. That may help you immensely. It also allows you for scalability. So maybe that process gets kicked off on a different server and doesn't affect the server that the primary users are using. Following up with that is allow for multiple instances unless it's somehow prohibitive. Security considerations sometimes mean that you can only have one instance of an object at a time. Sometimes race conditions and that will fall into will impact it. So you're like, oh, I can't have more than one instance working at a time. But ideally, everything should be set up so that that's not a case. You should be able to allow for multiple people to be working on the same chunks of data, and if need be, and handle updates and things like that. And along the same line, where you can, provide a hook or an API to avoid coding yourself into a corner. And don't, this goes back to limiting your assumptions, but the more that you can leave stuff open, that you can leave the option for people to extend, future developers or other users to either access your code via API. At some point somebody wants to come in and build API onto your code. If you're following these steps, you're probably going to be able to have stuff that's easier to convert to an API. The other side is people, if other developers come in or yourself and you want to extend it, the more you allow for that, the better. Best practices, very similar actually to databases. Try to avoid complex logic and magic numbers, things that just are not easy, that obfuscate the code, that make it a lot harder to read. Use meaningful names. So if you use, and I do this a lot, if you use X or I or J as variable names, it should only be in like for loops and obviously an index number, something that's not used anywhere else. If you come in and you're using, strings that you're doing a lot of manipulation on, and their variable names are A, B, and C, it's just hard to read. So don't do that. Use meaningful names. They don't have to be long. That drives people nuts, even with code completion, when it's like a 40-character long name. But if you have to abbreviate, make it very obvious what the abbreviation is, or add a key somewhere to say, this abbreviation is what I use in all. I use this throughout. So this is how I abbreviate this long word. For example, page, not a long word, but maybe you say everywhere I'm going to use a page variable, I use PG instead, or P, something like that. And just, put somewhere a sort of a legend of the conversions of names that you use. Particularly to object-oriented, keep your loops tight. It's really easy to get away from this when you're, as we talked about, if you've got hundreds of lines of code or thousands of lines of code and you're going in, you're converting some of this stuff into a method, then that method may be sitting inside of a loop, and there may be some stuff you do that method because you forgot you're in a loop, and now you're like maybe creating a lot of classes or making some database calls or something that you wouldn't have done, but because you abstracted it, you forgot that, oh, by the way, this is in a loop. So you want to make sure that you avoid that. Try to keep your loops tight, keep your code tight. Do what you can to, push off stuff as long as possible as far as creating something, unless it's something that you're going to be reusing, in which case, go ahead and do it once and just reuse it, create it outside a loop and reuse it within the loop. We'll get into this a little bit more when we talk about patterns and anti-patterns. Provide for exceptions and add in negative testing. Make sure that you're doing that you've got exceptions, that you've got error handling, and as part of your coding and part of putting these classes together, that you test them for things that will generate those errors, that generate those exceptions, and that to make sure they handle things correctly. You don't know, that's just key in object-oriented programming. You got to be able to handle users that have no idea how to use your class and they go throw in something weird. It should not cause, new World War III or, your entire app to just come to its knees because they put a negative number in instead of a positive number, or they put a number in instead of a string, or vice versa. That kind of stuff should all be, you should have validations and ways to make sure that that stuff doesn't happen. And where you can't stop it, make sure you're checking for those exceptions. And along those lines, validate all user entered data. You have no idea what they're going to do. They may be malicious. They may be just boneheaded. Maybe they didn't read the documentation. The F is in RTFM for a reason, particularly when doesn't stand for fine. So make sure you validate user entered data. Make sure that your stuff coming in is correct and clean. And like I said, if not, get you an exception. Bottom line, again, sort of what we ran into the databases. You start at the top, get your major objects and your actors, get those defined as classes. You add in details as needed, and those details are going to come from your use cases and your requirements. There's going to be basic, generic, global type functions like security-related stuff, log in, log out, logging it, audits, whatever it is, some sort of logging if you want to do, whether it's debugging or whether it's just basic application logging to help you when errors do arise, error handling and exception handling, things like that are just part of building an application. And of course, follow best practices. That's going to vary from language to language. That's again where it helps. If you're self-taught in a language, go do some Googling on best practices in that language. Maybe take a class somewhere along the way, look at whatever the official site is, follow some blogs, listen to some podcasts, those kind of things, so that you're using the language in the way it was intended to be. And there we go. We have flown through this. I apologize for that a little bit, but I want to make sure we kept this one a little bit short. As always, questions, comments, we're going to do a follow-up here, but also you can send them to info@developerpreneur.com. You can contact us on the site. Love to talk about any of these things, whether it's generic discussions or whether you've got some specific problems that you're running into, or design issues that you just want to bounce off of somebody else. That being said, I'd like to open it up to questions and comments. And everybody.
So with the object-oriented piece you're talking about with inheritance, and that, so take for example the tool I'm building that basically creates a framework for someone. Now that's a little more kind of to the nth extreme as far as inheritance goes, but when you're building something like that, or something large that is meant to be abstracted and extended, most of your classes would have some form of inheritance around them, or at least some type of parent-child relationship.
Well, at the end, yours may or may not. The end user definitely would. Hibernate's a good example of this. They, if we were building it, we probably would not build it that way. They've got a couple extra layers of how they do models and views and things like that they need because of the extraction level that they have. So, for example, because they have to support all these different databases and things like that. In your case, that is a good example. Is that what you would want to do? Is you're going to build a lot of core classes that the whole point is for them to be extended. Now, you may, as part of your building your application, you may essentially bootstrap pieces of it so that you actually are implementing on top of that framework in some instances, but maybe not. You may be able to build it all at a very thin level. It's just that the whole point is to build that in a way it's exactly the kind of concerns there is so that another user can come in and it's very obvious for them how to extend that, and that it's open to them to extend it.
So that's essentially so my tool is lightweight. My tool doesn't have nearly that level of extrapolation, but the framework it builds for you generates essentially an API that anyone can come in and follow. They can extend it any which way they want for any tool base they have for testing. So it pretty much follows your model. It's just the particular framework I have had to go to that level because of the extensibility that I wanted the end user to essentially have.
Well, in your case, it's an interesting one because I think correct me if I'm wrong how you did that, but basically you've got, it really is, it's just an interface. You've got a core engine that does does its stuff. And the way for people to access that engine is you've provided interfaces, essentially a framework that said, look, if you follow these rules, if you fit within these interfaces, then you're going to be able to use the engine properly. So it's you're really almost at that point, I think you said it, is you're really building an API more than you're building an application, because you've built that engine behind the API, but what you're really delivering to people is the API, which is a way for them to access your engine. Is that correct?
Correct. Yes, which in turn simplifies the layers and all the boilerplate that they have to deal with.
Yeah, which is not, it's the nature of the beast in that. For example, I've got, and you've seen some similar tools that we've got, and we've even talked about building some where you're building a code generator of some sort. For example, the well-known things like Roo, and some of the things that are out there, Hibernate, things like that. If you're going to do a code generator, like I did, is one of the things I had as an option where you could build, you could go define your objects, you define your attributes, and then, of course, you could check some buttons and add like database interaction stuff. You could add some logging stuff, some output stuff, a bunch of these different things. Well, what those generate are classes. And you could just go in and, in that case, since it was generating code, it's a code generator versus yours is really more an API. Since it's a code generator, in that case, you have the core classes, and you could go in and tweak those. Because that's part of what it delivers you your core classes, but it does it in a way that if you want, which is similar to Hibernate, if you want, and if you do it correctly, you're going to extend them. Because the one thing we haven't talked about here is that if you build it for extension, if the underlying code changes, which this is an issue you run into as well, if the underlying code changes, you want to make it so that the work somebody did has not been invalidated. So like in your case, you've got this engine and you've got this API, and you're basically saying, hey, if you stick to the API, I may change some such stuff in the engine, but I still have that abstraction point. So I'm not going to cause all your code to blow up and you have to start from scratch. Or right. I'm going to be able to at least generate the pieces I need to, because I know how you've built your application. I've actually, given you a template. I've given you a contract to work with your application. And the contract says you stick to that, and I'm going to limit the amount of damage that gets done if we change anything.